Okay, good morning to you all. Math is easy for me, first of all. All of us, we need to believe in ourselves that math is easy for us. Today we are going to do these numbers. This is our number 1. This is our number 2. They came in wakisha 2024. Our number 1 says that calculate the coordinates of the point of intersection of the curve this and the line this. They want the point. Assume this is our curve and this is our line. So this point where 2 bits is the point of intersection. They want the point where the curve meets this line. So I'm going to divide it through by y here. I get x over y minus 2 over y is equal to 0. This implies that x over y is the same as 2 into y plus 1 over y. After making x over y the subject, I get this. So I'm going to divide it to substitute it here. I get this is x over y plus 60, y over x is equal to 5. Substitute this in this equation. So you get 2 into y plus 1 over y, then plus. Now this is y over x. This is x over y. But remember, this is y over x. So it is a reciprocal of this. So here you get plus 6 reciprocal of this, which is y over y plus 1. But there is this 2. Then is equal to 5. Then this 2 reduces with this 6. We remain with 3. So therefore, we get 2 into y plus 1 over y, which is equal to, it is plus 3y over y plus 1 is equal to 5. Then from here we get the LCM. After getting the LCM, we get something like 2 into y plus 1 squared, then plus 3 y squared is equal to 5y into y plus 1. Then we expand these equations. Here we get 2y squared plus 4y plus 2 plus 3y squared is equal to 5y squared plus 5y. After expanding this, you get this. Then if you open the brackets here, you get 5y squared, then plus 5y. Then this 2y squared plus 3y squared, it cancels with 5y squared. This one, and this one, and this one, they cancel. So I remain with the 4y plus 2 is equal to 5y. This implies 2 is the same as 5y minus 4y. Therefore, our y is 2. That is the value of y. Now we are getting the value of x. We are going to substitute our y here. So from x minus 2y minus 2 is equal to 0. It implies x minus 2 into 2 minus 2 equals to 0. We have substituted this value of 2 here to get the value of x. Therefore, x is the same as 6. After placing your calculator, you get x and 6. You make a conclusion that x, y is equal to 6, 2. And this is the point of intersection of the line and the curve. That's number 1. Now we are going to number 2. Number 2, it says, by using a suitable substitution, evaluate the integral from 0 to 1, x over root of 1 plus x dx. They have even gave us an idea that we are going to use the substitution. But some of us may think of tan substitution or sin substitution, but it is very rare for us to find a sin substitution or tan substitution in section A. So this is the U substitution. What are you going to substitute? It is this root, because it is difficult for us to integrate a root. So we are going to say let U be equal to root of 1 plus x, because it is difficult for us to integrate a root. So we get U squared is equal to 1 plus x after squaring both sides. Then we differentiate this side and also differentiate this side. You get 2u du is equal to dx after differentiating. Now we substitute back these values here, but before we need to change the variables. We draw some small box here. This is the x, this is the u. Remember, u is the same as root of 1 plus x. So if x is 0, what is the u? U is going to be root of 1 plus 0, which is a 1. So if x is 1, what is going to be our u? Our is going to be root of 1 plus 1, which is root of 2. Then we substitute back everything here. So we are going to get, therefore, integral from 0 to 1 of x root of 1 plus x dx. It becomes integral of 0 become a 1. Then 1 becomes root of 2. Where there is x, I'm going to put there u squared minus 1 from here. U squared minus 1 over, then the root of this is u. Then our dx is here. Our dx is 2u du. Now this u, it cancels with this u. So this integral becomes integral of 1 root of 2 u squared minus 1 times 2 du, which is the same as 2 integral from 1 to root of 2 u squared minus 1 du. Then you integrate from there. You get 2 into, if you integrate this, you are going to get u cubed over 3 minus u. Then you put limits as 1, 2. Some of us, after integrating, you add a constant, but you add it when you don't have limits. If you have limits, there is no need of adding that constant. So let us substitute the limits. The first limit is going to be 2 into, it's going to be root over 2 cubed over 3 minus root over 2. Then in minus, substitute for 1. You're going to get 1 cubed over 3 minus a 1. Then you need to simplify this answer to the C.